The Great Pacific Garbage Patch is the largest accumulation zone of plastic in the ocean. It covers an area that's about 3 times the size of France. When you go out there, it doesn't look all that different from anywhere else in the ocean. You might see a buoy or a net in the water every once in a while, but it's very dispersed. Even today, I'm dumbfounded that in every single net that we throw overboard, you're going to find plastic. We have polluted one of the most remote regions of the world. It's a tragedy of human creation. But we did this, and we also have the power to clean it up.
I've been fascinated by technology all my life. I was never bored as a child. I always had my projects. When I was 16, I went on a family vacation and I thought it would be cool to scuba dive. And I was hoping to see all these beautiful things like you see in the nature documentaries. But then I was underwater for the first time and looked around me and it was just this garbage dump. I realized this is not something local in a little bay in Greece. This is one of the largest threats our oceans face today. That was the moment that my innate passion and interest in technology came together with this realization that we have some real big problems on Earth that we need to solve. The best way to solve a problem is to actually break it down to small pieces that each are solvable.
I'm a naval architect by trade. I've been sailing all my life. I look at the technical side of solving this plastic pollution problem, working with our teams in oceans and in river projects to develop technology that doesn't exist. We come up with some concepts, and then we start to test as much as we can, as early in the process as we can. We collect a lot of data in those tests that we're doing, but for some aspects it's very hard to collect data. So for instance, where the plastics specifically are in the ocean, that's very dynamic. They move around, they form higher density areas, lower density areas. And for that we use very extensive numerical modeling. Now that we have some experience operating in the ocean, we get more and more sort of ground truth data for that modeling. It may look relatively straightforward. We go out there and troll through the ocean and then get the plastics out, but there's much more to it.
As a lab and field scientist, I participate in most of our field missions and then also oversee the processing of our samples back home. Our data is a pretty unique set of samples from an understudied region of the globe. We have been able to collect 7-8 years of really high-quality data on where the plastic is accumulating and where it might be coming from. Around 80–85% of the material that's found in our cleanup system is somehow derived from fishing gear. Most other research ventures, they don't get that continuous sampling. We are big believers in open source and open access data. Once we've characterized the plastic samples for our database, we archive them, and if anybody wants them, they can reach out to us. We send plastic all over the world, basically, for people to study it.
Data is super important to my team. Catch Management Director is not a usual job title. What I do here at the Ocean Cleanup is once we take out trash from oceans and rivers, make sure that it doesn't return to the environment.
There's weird stuff out there. It shouldn't be.
Crates, toys,
fridges,
office chairs,
the surprising amount of toilet seats.
Whatever you can think of and floats could be in the garbage patch.
53.2.
We document every step of the process. For that chain of custody, traceability is based on having data of each step in the process. So managing that data is a big task. We're still using Excel spreadsheets, whereas we need to move to something more substantial to manage all the data. Data about the composition of the catch, characteristics of the end products. That is all data we need to build to be able to learn and really understand what we're working with. Once we recycle the catch, we make sure that it ends up in products that are useful and durable so that it doesn't end up back in the ocean.
The way our ocean cleanup system works is that we have a system comprised out of 2 ships and a retention system in the middle, which is a 2 to 2.5 kilometer long floating barrier that funnels the plastic to the center, where you have a collection bag. We call that the retention zone. Whenever it's full, we bring that retention zone on the deck of one of the ships.
Wow,
We empty it, we redeploy it, and we keep cleaning.
it's a big pile.
With the current cleanup system, essentially the hardware component of it, the big U-shaped barrier that we tow through the ocean, that's pretty much done and it works fine. Where we really need the cycles of learning is actually in the software side, deciding the optimal path for these systems to travel.
We want to be the most efficient that we can in catching the most plastic. The worst thing would be if we're burning fuel for nothing.
The core technical challenge for us is how to predict where those hotspots form so that we can specifically target those areas where the highest congregation of plastic can be found.
At some point, we were running a 3-dimensional numerical model of the whole North Pacific Ocean. We're developing artificial intelligence systems that can, using cameras from the ship, detect plastics, identify what type of plastic it is, how large it is, the velocity it's traveling at. And that is giving us information on are we in the right location and how much is entering our system. Every time I see that whole big bag of plastics coming onto one of the vessels, I'm amazed how much is coming from that super remote area that should be a pristine ocean but isn't.
We haven't solved plastic pollution yet. We cleaned up about 0.25% of the Great Pacific Garbage Patch. But those small fractions and small percentages, they do prove that we can do it.
Finding practical ways to actually solve environmental issues, I think that's a spirit that guides the whole company. We are people that are just trying to get it done.
We hope that our job will be done within 10 years from now.
Our objective is to put ourselves out of business. We are very optimistic that the problem can be solved using technology, but at the same time, human behavior also needs to change.
Probably the most important thing you can do, whenever you see plastic in the environment, take that out. When you go for a walk on the beach or whatever, the chance that the plastic that you use, that actually ends up in the environment, as long as you don't litter, it's very low. I try to use my skill sets to the best of my abilities to maximize the impact I can have on this problem. One person can, in fact, make a huge amount of difference on the world.